Okay, here we go. This is the worksheet for section 511, which is factoring, and we're going to factor completely, but we're going to apply several methods. So we may use one of these techniques, and let's talk about the different types, right? We have what types of factoring, types of methods, factoring methods, that's what I'm going to call it. So we can factor. One method is a common factor, something that can have a common factor, and we typically want to take the greatest common factor. So not only is it a common factor, but it behooves us to take a greatest common factor. Another factoring method is going to be the difference of squares. And these are a mental one. We're just going to mentally see how we can transform the expression into the product of two binomials. The next one is a binomial square. Both of these are going to use mental factoring. It's not a technique. Technically, there are techniques and characteristics about those, but primarily it is a mental factoring. The fourth one is A times C, and that has a procedure. And then the fifth one is factor by grouping. Again, there's a technique that we're going to apply. But we're going to look, and maybe we do a number 1 and a number 2. Maybe we do a number 2 and then we can still do number 2 again. Yeah, we remember that one. Right? I don't know if you remember. Let's do that, right? That becomes x squared minus 4, x squared plus 4. Excuse me. And then we can still factor this again. So that's an example of several methods that we would factor completely. So you factored, and then we would have to factor again. So that's what these problems are going to focus on. So we always look and see, is there a greatest common factor amongst the terms? And I'm always going to look at the smallest number of the group, 4, 28, 40, and I'm going to look at the factors of 4, 1, 2, and 4. And I'm going to start with the largest number. Somebody had mentioned that in class, which I thought was great. We're going to start with the biggest. Does 4 go into 28? Uh-huh. Does 4 go into 40? Yes. So I know that my greatest common factor is going to be 4. That gives me x squared plus 7x plus 10. So I was able to find a greatest common factor. I pulled it out, and now I'm looking at this term, and can I still factor this? So it has 3 terms. So technically I was showing you that you would go through this criteria. Difference of squares would be next on that list. I don't have to do difference of squares. Difference of squares is 2 terms. This is 3 terms, so I can literally skip to however many terms. So the third one in the list is a binomial square. And I have to look at the characteristics of a binomial square. All right, binomial square is 3 terms. This has 3 terms. Second sign positive. This has a second sign positive. The first and third are perfect squares. The first is a perfect square, but the third is not a perfect square. So I know that it's not binomial square. So I have to go to the next one. So I'm going to bump down. And the fourth one is A times C. And we'll notice that these two deal with 3 terms. So that's why I can jump to 3 and 4 when I have 3 terms. I jump to here when I have 2 terms. And I'm going to jump to here if it didn't have, if my term had more than 2 or 3 and had 4, I would do factor by grouping, which would be 4 terms. So I could jump 2, 3, and 4 if it has 4 terms. I can jump 2 if it has 3 terms, and I would start with difference of squares if it had 2 terms. So in this case, I'm going to try A times C, the A times C method. So A times C, let's maybe group and make this a wee bit smaller. Good, so my A times C. My A is 1, my C is 10. 1 times 10 is 10. Factors of 10 are 1 and 10, 2 and 5. My signs, because it's a positive, I know my signs are the same. And I'm going to look here and I see that they are both positive. So plus, 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 plus. I get 11, I get 7. 7 is my middle, so I'm going to use these two numbers to split up my middle term. I'm rewriting the GCF outside and I'm changing this term. So it's x squared instead of 7x, I'm writing plus 2x plus 5x plus 10. And now I'm going to factor by grouping. So I'm going to group the first two and the second two. And this is typical of what we do. So the first two I can factor out an x and I get x plus 2. Second two I'm going to factor out a 5 and I get x plus 2. You want to get so good at this that you can look at that and you can do the factor by grouping. Since they both have an x plus 2 in common, I know I did it right, and I'm going to pull that out, and that would leave me with x plus 5. Notice the 4 times stayed outside because I had that as my factor. So my answer is 4 times the quantity x plus 2 times the quantity x plus 5. Let's look at the next one. It has 3 terms. The first thing I'm going to do is I'm going to see, is there a greatest common factor? I'm going to look at the smallest value. Can 3 go into 36 and 60? Yes, it can. So I get r squared plus 12r plus 20. I don't have to do difference of squares because that's 2 terms. I'm dealing with 3 terms, so I'm going to skip to 3, which is a binomial square. 3 terms, second sign positive. First is a perfect square, but 20 is not a perfect square. So I'm going to move along to a times c. My a is 1, my c is 20. 1 times 20 is 20. And the reason why I can do this so quickly is because I've done it so many times that I know the process inside and out. The way that I can get factors of 20 is because I've done the factors of 20 so many times. I know that that sign means they're the same. I know that that tells me that they're both positive, that I'm looking at those things. And I'm going through this same routine because I've done it so many times that it's just rote. My middle is 12, so I'm going to take those 2 terms. I rewrite this trinomial into 4 terms. So I get r squared plus 2r plus 10r plus 20. I'm going to factor by grouping the first 2 and the second 2. I have 3. I'm going to factor out an r from the first 2. I'm going to factor out a 10 from the second 2. And I have my answer as fast as that. And if you can do it, and it's not about speed. Don't want you to think that you have to be fast for it to be valuable. Fast tends to get you into trouble and you make silly mistakes. I'm fast just because I've done it so many times. But you want to be efficient. I'd much rather you be efficient than fast. All right? So that would be your answer. This one, we still check, is there a greatest common factor that I can take out? I can take not only a 3, but I can take an x from both of those. So if I factor out a 3x from 3x squared, I'm left with x. I'm going to factor out a 3x from 21, and I get 7. I'm not done. I'm going to check this. This has 2 terms. Remember, 2 terms. I'm going to check for difference of squares. Difference of squares is 2 terms. It's subtraction between both of those. And in this case, it's addition. So I know that this is not difference of squares. I wouldn't check 3, 4, and 5 because 3 and 4 deal with 3 terms. We only have 2. And 5 deals with 4 terms. And we have 2. So we can't factor this any further. This is completely factored. So that would be my answer. Let's check on number 4. Is there a greatest common factor? Since my first term is negative, I have to factor out a negative. I'm going to factor out a negative 2, and I get p squared minus 81. Good. So I'm going to go here. I have two terms. Difference of squares. Is it a difference of squares? Is it three terms? Is it subtraction? Yes and yes. Are both of my terms perfect squares? Perfect square and perfect square. Good. Now, not only is it important for you to notice that it's the difference of squares, but equally as important is what does it produce? I found that when students got here and knew that it was a difference of squares, that they didn't understand what it factored to. And it factors to conjugates. And the way we find out what those conjugates are is you take the square root of p squared, which is p. That would represent my first in each of the binomials. And I take the square root of my last, which is 9. And remember, difference of squares deals with conjugates. So conjugates are opposites. And we know that they have to be opposites because this starting expression, this binomial, it was missing the middle. Why is it missing? Why does it only have two terms? Well, it only has two terms because 9p, my inside and outside are opposites. And they cancel, so that's why there's no middle term in this binomial. So they have to be conjugates. Okay, so there is a clear understanding. You got to know this stuff inside and out on why we do it and what it produces. Then we would look at these again. Are those are two terms. Are those difference of squares? Two terms, subtraction? No, not subtraction. Two terms, subtraction, yes. Perfect squares? Yes. But no, p is not a perfect square, so I know that this is factored completely. I can stop. Let's look at here. Greatest common factor. I see my first term is 3. 3 goes into 18 and 24, so we're going to factor out a 3. We get negative 6n plus 8. We have 3 terms, so I know that it's not difference of squares. I'm going to check and see if it's a binomial square. 3 terms, yes. Second sign positive, yes. Both perfect squares. N squared is a perfect square. 8 is not, so it is not a binomial square. So I again have to revert back down to a times c. 1 times 8 is 8, factors of 8. My signs are the same, but this time they're both negative. So negative, 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 negative 9, negative 6. Negative 2 and negative 4 are equal to my middle. So n squared minus 2n minus 4n plus 8. Factor by grouping. I'm going to factor out an n from my first two. It leaves me with n minus 2. I'm going to factor out a negative 4 because my first term of my second group is negative. So I'm going to factor out a negative 4 and I get n minus 2. Those have to be the same. If you wrote n plus 2, you would know you made a mistake because it's not like the first parentheses. But because I factored out a negative, I know that when I take negative from a positive, it leaves me with a negative. So my answer is going to be 3 times the quantity n minus 2 times the quantity n minus 4. Number 6, factor out, greatest common factor. I'm going to factor in a negative 2. I get x squared minus x minus 6. Also, be careful of those signs. Negative 2, if we divide negative 2 by a positive, we get a negative x. Positive 12 divided by negative 2 is negative 6. That's why those values are negative there. And also, if we redistribute it, you better get your starting problem. Lots of stuff there to contemplate. And that is number sense. We have to understand what we're doing. All right, not the difference of squares. It has more than 2 terms. Is it a binomial square? No, 6 is not a perfect square, and second sign is negative. So we got to do a times c. A is 1, c is negative 6. Factors of -6, 1 and 6, 2 and 3. My signs are different. When that sign is a negative, I know they're different. And this tells me that the bigger of the two is negative. So 6 is bigger than 1, so 6 gets the negative. 3 is bigger than 2, so that gets the negative. And the signs have to be different. We see 6 is negative, 1 is positive. That gives me -5. This gives me -1. My middle is -1. There's a -1 right there. So this becomes -2 times quantity x squared plus 2x minus 3x minus 6. Factor by grouping. And that makes sense logically because we have 4 terms. 4 terms, we factor by grouping. So we can even revert back to that ideology. So let's look at the first 2. We're going to factor out an x. You get x plus 2. We look at the second 2. We notice it's a negative. So we're going to factor out a -3, x plus 2. And we get -2 times the quantity x plus 2, x minus 3. Your goal is to be that efficient. Whoa, look at those numbers. Holy schmoly. 28, 248, 320. I'm not going to worry about 320 and 248. I'm just going to worry about the factors of 28. I'm going to be looking at numbers of 1 and 28, 2 and 14, 3. I don't think so. 4, yes, 4 and 7. 5, no, 6, no. So I'm going to be looking at 1, 2, 4, 7, and 14 and 28 to see if they go into 248 and 320. So I pull my calculator out. You're allowed to use a calculator. Use it. All right. We know that 2 goes into 248 and 320 because it's an even number. So I'm good with 2. Let's look at 4. 248 divided by 4. All right, that goes in evenly. Now let's try 320. Yes, 4 goes into 320 80 times. So I know 4 goes into all 3 of those numbers. 4 goes into 28, 248, and 320. Let's try 7. So 248 goes into 7. No. So 7's a no-go, not 7. 14 won't be also because that is a multiple of 7. And pretty sure 28 doesn't because 7 is in the 28. So my GCF is going to be 4. So I'm going to factor a 4 from that. That goes 7n squared. Let's do 248 divided by 4. This is going to be a huge number, 62. Oh my goodness. Oh my goodness, what was I thinking? 62. 62 and, oh, I'm sorry about this one. 320 goes 80 times. Oh my goodness. Mr. Mack, you were not very nice with problem number 7. All right. Now, just to check, just to make sure, I would still look at these 3 numbers and make sure that there isn't a common factor. 7's pretty easy. Does 7 go into 62 or 80? No, it doesn't. So I know that I took out the GCF. All right, so that was GCF. 2, not the difference of squares. 3, binomial square? No, 80 is not a perfect square, nor is 7. So we got to do A times C. Mr. Mack. A is 7, C is 80. That's 560. Yowzers! Factors of 560. Mr. Mack, that's not very nice. 80 equals 560. Okie dokie, 1 in 560. We know the signs are the same. And keep this in mind while we're doing this. And they're both going to be positive. So we know that we're going to add them. What factors of 560 when added equals 62? Well, we know it's not going to be 1 in 500 because that gives me 561. We know it's not going to be 2 because that's 280. That's 282. So we're looking for 62. 3 goes into 560. Does 3 go into 560? 560 divided by 3. No. So 3 doesn't go into it, 4 does, and 4 gives me 140. And the reason is I looked at 2 times 280, and I would just take, right, how do I go from 2? I would need a 2. So if I pulled the 2 from 280, that would give me 140. And that would give me 144 when added. 5, yes, 5 goes into it because it ends in 0. So that goes in 1, 1, 2. That gives me 117. 6, no, because it didn't go into 3. Because multiples of 6 are go into 2 and 3 also. 6, 7. Yes, we know 7 and 80. That gives me 87. We're getting closer to 62. 8, yes, 8 goes into it. 8 goes into it 70 times. So that gives me 78. 9, no, because 3 doesn't go into it. 10, yes, 10 and 56. And hey, that gives me 66. We're really close now. 11, I don't think 11 goes into it. 12, I think 12 goes, no, because 6. 13, 14, there it is. 14 goes into it because 14 goes into 7, and that would be 14 and 40, which gives me 54. We missed it because it equals 60. Mr. Mac, did you see what I made? See the mistake I made? I'm sure some of you were screaming, Mr. Mac, you made a mistake way, way, way back. Oopsies. Mr. Mac made a mistake. That should be a minus. So we know the signs aren't the same. The signs are actually different. And the bigger is positive. So let's go back here. We still needed to do these factors, but we just have subtractions, and we're subtracting, taking the difference between these two. Bigger is positive. All right, positive, 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 positive. Minus. And remember, it has 62, so that's this one. 70 minus 8 is 62. So notice I came up with an issue. When I was adding, there was no 62. So I went back to my work because I knew I had to have made a mistake somewhere. So that's why I took the time to go back and notice I made a mistake, go check, I found my mistake, and now I'm able to be successful. Look, in all honesty, we're all going to make mistakes, even Mr. Mac. So it's when it doesn't make sense and it's not adding up correctly, what do? Do you keep trudging along and ignore the fact that it didn't make sense logically? Or do you stop, look at your work, and notice my work is organized so I can look at it and make sense of it, and I was able to find my error. So we're going to factor out an n, and we get 7n minus 8. We're going to factor out a 10, and we get 7n minus 8. And we are on the road to a correct answer. Ding, ding, ding. There's a lot of value in that problem. All the difficulties, we still were able to make it come out correct. All right, common factor, or GCF should I say, 18, 96, 72. I'm going to check and see if 18 goes into 96 divided by 18. No, it does not. So now I'm looking at factors of 18. 9. So we have 18, 2 and 9, 3 and 6. So 96 does not go into 9. So what? 96 divided by 9 is 9. So 9 doesn't work, 18 doesn't work, 9 doesn't work. Let's try 6. 96 divided by 6, 16. Good. And does 6 go into 72? Yes, 12 times. So I found my GCF is going to be 6. 6 goes into 18, 3. 6 goes into 96. What did we say, 16? 96 divided by 6, 16. Good. 16x. I'm not going to make the mistake that I made before. I'm actually going to bring down the negative, and 6 goes into 72 12 times. So we look at 3, 16, and 12, no common factor, so I know that I took out the GCF. And it takes 2 seconds to check that, just to double check and to make sure. 2 is difference of squares, no. 3, binomial square, no. 4, a times c. All right, we got 3 times negative 12 is negative 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 no, 6 and 6. Signs are different. Bigger is positive. 35, 16, 9, 5, 0. So 16, I got that. I got you, babe. 6 times the quantity 3x squared minus 2x plus 18x minus 12. Factor by grouping. 6. We're going to take out an x. We get 3x minus 2. We're going to take out a 6. We get 3x minus 2. And that leaves me with 6 times the quantity 3x minus 2 times the quantity x plus 6 would be my answer. We're halfway there, baby. GCF, 2 goes into it, 4 doesn't, 5, so 2. We're going to factor out a 2, 5n squared plus, not 18, 16n plus 12. I'm looking at 5, 16, and 12. No numbers go into it, so I took out the GCF. Not difference of squares, not a binomial square. A times C. A is 5, C is 12, 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, that's a tricky one, 5 and 12, 6 and 10. Signs are the same, both are positive. Equaling 16 would be my last two, 6 and 10. So we get 2 times the quantity 5n squared plus 6n plus 10n plus 12. It's going to be the longest video I've made all year. Factor by grouping. We're going to take out an n. You get 5n plus 6. Take out a 2. And we get 5n plus 6. I did it right. 2 times the quantity 5n plus 6 times the quantity n plus 2. Boom, baby. Oh, I like this one. 2 terms. We still look. Greatest common factor. I have a leading term that is negative, so I have to take out a negative something. They both have an a, so it's negative 42 and 60. Yikes. 42. Factors of 42 are 1 and 42. 2 and 21. 3 and 14. 4, no. 5, no. 6, yes. 6 and 7. All right, what goes into 60? 1, 2, 3, 6 goes in, 7 doesn't. 14 go into 60? I don't think so. Takes 2 seconds to check. B, nope. So 14, no. 21, no. 42, no. So my GCF is 6. So 6A, I don't want to insert a compass. I don't know why you're doing that. So I'm going to factor out a negative 6A. That gives me 7A minus plus 10. 7A plus 10. See how I took this time? I had a negative. When you're dealing with negatives, take your time and just make sure. I look at this. two terms, so I think of difference of squares, but this is not difference of squares because it's not subtraction. So I can't factor that any further, and that would be my answer. Again, GCF 2836, 128, 2 and 14, 3, 8, 9, 10, no, 4 and 7, 5, no, 6, good. All right, so what goes into 36? 4 goes into 36. So if I factor out a 4K, that leaves me with 7K plus 4 goes into 36 9 times. And there's no common factor between 7 and 9. And not the difference of squares, so that would be my answer. We like those. Oh my, here's another big one like number 7. Alrighty, greatest common factor. So I'm looking at 21. 21? I'm going to first look and see, just for kicks and giggles. All right, 21 does not. So now I'm going to look at the factors. I just test it real quick. 2, no, 3, and 7, and that's it. All right, does 7 go into 144? 144 divided by 7. Nope. 144 and 3. 144 divided by 3. Yes, 48. 192 divided by 3. Yes, 64. All right, so 3 is my greatest common factor. So I'm going to factor a 3. I knew that was going to be bad. I'm going to factor out a 3, and I get 7x squared. I already forget what 3 divided by 144. 144 divided by 3 gives me 48. And 192, I've already forgotten. 192 divided by 3, 64. Minus 64. Mr. Mac gets a little lazy with those negatives. All right, here we go. So, A times C, it's not difference of squares. It's not a, almost close to a binomial square. That is a perfect square. This is not positive, so it's not binomial square. So I got to do A times C. A is 7, C is negative 64. Yikes. Those are a lot of factors I'm going to have to do. 448, negative 448, 1 and 448, 2 and 224, 3, no, 4, yes, 4 and 1, 12, 5, no, 6, no, because 3 doesn't go in it, 7, 7 and 64, 8, yes, 8 and 56, and there it is. How do I know there it is? Because I know my signs are different, and so I have to subtract these factor pairs. The bigger is going to be positive and negative, and that gives me 48. Sorry. I take 8 from 56, I get 48. So there are my factor pairs. So I don't have to keep going if I see that I didn't make a mistake. And that'll save you a little time. All right, we're going to factor by grouping. So I'm going to factor out an x. I get 7x minus 8. 56 and 64. I think 8, yeah. So I'm going to factor out a positive 8, and I get 7x minus 8. So my answer is going to be 3 times the quantity, 7x minus 8, times the quantity x plus 8. Wow. Oh, another doozy. Greatest common factor. I'm only on 13. We got 18 problems. This is going to take almost an hour to do. Longest video. All right, negative first term, 27, 72, 48. Kind of want to check 9. 9 doesn't go in. 3. 6 times 8 is 48. 6. Now I'm going to say it's negative 3. And I'm going to take a guess. I'm going to sort of feel that it's in that area, and I'll tell you how I can check and make sure that I did it right. So I get 9x squared plus 24x plus 16. And I'm going to check those numbers because it takes 2 seconds. Just 72 divided by 3 gives me 24, and 48 divided by 3 gives me 16. So I did that right. Now I'm looking at these numbers, 9, 24, and 16. There's no number that goes into 9 that goes into 24 or 16. So I know I did it right. Difference of squares? No. Binomial squares. 3 terms. Second sign positive. Both perfect squares. And remember that fourth criteria is, does my middle equal 2 times the square root of the first times the square root of the last? Square root of the first is 3x. Square root of the last is 4. 2 times 3x is 6x. Times 4 is 24x, which equals my middle. So I know that this is a binomial square. So what does that produce? Much like way back here, when it was the difference of squares, what does it produce? Yes, you can figure out that it is, but how do you remember what product of binomials does it produce? So that'll be very important here. So I know that it's a binomial square, so I know it's going to be 2 terms being squared, hence the name binomial square. How do I get these 2 terms? I take the square root of the first, I take the square root of the last, and I pull the sign of the first. So my answer is going to be -3 times the quantity 3x plus 4 quantity squared. We're going to look. I'm going to find a greatest common factor, negative first term. They both share a p. 12, I think 108 divided by 12 is 9. Yes. But I check. So I can take out a negative 12p. That leaves me with p plus 9. I check, make sure that that is right, and it is wrong. It has to be a minus. Notice I took the time at the end to check my answer. Make sure, it takes you 2 seconds to do it back out to make sure that when you have your negatives that they make sense. This is not the difference of squares because p is not being squared. So that is all you can factor that binomial. 36r squared plus 36r plus 40. 4 goes into it. I'm going to try 4. 4 gives me 9r squared plus 9r minus 10. Pretty sure that's correct. That looks good. It is not a binomial, right? That's my greatest common factor. Not difference of squares. Not a binomial square. A times c. We're back to a times c. 9 times negative 10 is negative 90. 1 and 90. 2 and 45. 3 and 30. 4, no. 5, yes. 5 and 18. 6, yes. 6 goes into 90 15 times. That's a tricky one. 7, no. 8, no. 9 and 10. Signs are different, and the bigger gets the positive. And we're looking for a positive 9, and that's that one right there. So we get 4 times the quantity 9r squared minus 6r plus 15r minus 10. Factor by grouping. I'm going to factor out a 3r. I almost did just an r. 3r gives me 3r minus 2. I'm going to factor out a 5, and that gives me 3r minus 2. So I get 4 times the quantity 3r minus 2 times the quantity 3r plus 5. Well, that's a good one. All right. couple more, 3 more. Here we go. 36, 116, 24. Let's see if 6 goes into that. 116 divided by 6. No. So I'm going to do 4. I know 4 goes into it. 6, 7, 8, not 9. Good. So I'm going to factor out a 4. That gives me 9x squared. 116. 116 divided by 4 gives me 29. That's an obscure one. 29x, and that's 6. So I know that I factored properly, not a binomial square, not a difference of square. So I'm going to do a times c. 9 times 6 gives me 54. 1 and 54, 2 and 27, 3 and 18, 4, no, 5, no, 6 and 9. Signs are the same, both positive. What add up to 29 are 2 and 27, 4, 9x squared plus 2x plus 27x plus 6. Factor the group. I can take on an x. I get 9x plus 2. Factor a 3. And I get 9x plus 2. My answer is 4 times the quantity 9x plus 2, x plus 3. 36 and 80. I think 4. Let's check it out. 4 goes into 36 9 times. 4 goes into 124 31 times. Right, 4 goes into 12 3. 4 goes into 1. 4 goes into 80 20 times. I got my signs all mixed up. That's a negative. So you see that I constantly make that mistake. So I'm always checking. Whenever I see negatives, I'm constantly checking to make sure that they ended up right. 9, 31, and 20, 36, 31, and that's correct. So I have 9 and negative 20, which makes negative 180. 180. My signs are going to be different, and I'm subtracting. 2 and 90, 3 and 60, 4 and 45, 5. Ooh, 5 and, I don't know that one. 180 divided by 5. Takes 2 seconds to use a calculator. 36, 6 and 30. Subtracting, which one? Oh, this one. There's my 31. Signs are bigger. Positive is smaller. So I'm doing 4 times the quantity 9x squared plus 5x minus 36x minus 20. I'm going to factor out just an x. I get 9x plus 5. Factor out a negative 4. And I get 9x plus 5. And my answer is going to be 4 times the quantity 9x plus 5, x minus 4. Last one, baby. Here we go. Negative first term. 6 goes in all those, so I'm going to take on a negative 6. That gives me 10x squared plus 7x plus, no, that's minus 7x minus 6. That's good. I got negative 60 as my a times c. 1 and 60, 2, 30, 3, 20, 4, 15, 5, and 12. Signs are different. Bigger is negative, so I have positive 5, negative 12, negative 6 times 10x squared plus 5x minus 12x minus 6. Negative 6. I'm going to take out a 5x. That leaves me with 2x plus 1. I'm going to take out a negative 6. 2x plus 1. And my answer is negative 6 times the quantity 2x plus 1, 5x minus 6. Woo, baby. Hopefully you stayed the whole entire time. If you did, congratulations. If you didn't, it's okay. But those are all the answers also. In case I made a mistake, you can check against that. But I'm pretty sure I did okay. Have a great time. See if you have questions.